it's now time to start looking at floating point numbers. Unlike whole numbers, floating point numbers have fractional parts that we express with a decimal point. In this table, you can see some examples of both whole numbers and floating point numbers in comparison. Floating point numbers are also known as real numbers. The examples on the left show 2 positive, numeric literal integers and 1 negative long. The examples on the right show just a couple of ways to express floating point numbers. We use a floating point number when we need more precision in calculations. There are 2 primitive types in Java for expressing floating point numbers, the float and the double. The double is Java's default type for any decimal or real number. When we talk about floating point numbers, we talk about both the width and the precision of the type. Precision refers to the format and amount of space occupied by the relevant type. This table shows the width of each of the floating point types and their ranges. The ranges are shown in Java's scientific notation, which we show below in blue colour. You can see the E notation followed by either a positive or negative number. Scientific notation can be translated into more familiar terms by replacing the E in the number with the phrase times 10 to the power. So we can say the minimum value of a float is 1.4 times 10 to the power of minus 45 and its maximum value is approximately 3.4 times 10 to the power of 38. Think about that for a moment using the double's minimum value shown below, remembering that 10 to the power of minus 1 equals 0.1 and 10 to the power of minus 5 equals 0.001 for example. Imagine writing out the double data type's minimum value in decimal format. That would be a lot of zeros after the decimal. I hope you can see that a double can represent a much smaller decimal value than a float and also a much larger decimal value than a float, which is why it's called more precise. Because it's more precise, Java chose it as the default type for floating point numbers. So now that you know what kinds of values a float and double type will store, let's go back to JShell and see them in some Java code. Alright, so now that we're back in JShell, let's confirm what we saw on the slide, what those ranges are. We'll do something similar to what we've been doing for other primitive types by retrieving their min and max values from the related wrapper class. We'll do that with a statement that might look familiar to you now. This code is similar to the way we got ranges for the whole number data types. System.out.print, opening parentheses, opening double quote, float value range, opening parentheses, opening double quote, plus float.min underscore value, plus opening double quote, to closing double quote, plus float.max underscore value, plus closing double quote, closing parentheses, closing double quote, closing parentheses, semicolon. Remember we're using the wrapper float with a capital F and getting both the min underscore value and the max underscore value and printing it with informative and formatted text. Now let's execute this by hitting enter. And you can see in the output that we have the values we saw on the slide. Now let's do the same thing for double by replacing float with double in the last statement and executing that statement. And you can see again in the output that we have the values we saw on the slide for double. So you really can see there that a double can work with a much bigger range of numbers, and it's also a lot more precise than the float. But of course, on the other hand, it needs twice the amount of memory, 64 bits or 8 bytes, to store that number compared to the float, which requires 32 bits or 4 bytes to store its number. Now that we conceptually understand floats and doubles, we're going to take a look at how to use some of these variables. We'll start by declaring 3 variables, an integer, a float and a double, and you'll see why later on in the video. We're going to do this on a single line in JShell again because it's a bit more convenient and I think easy to see. Int my value equals 5, semicolon, float, my float value equals 5, semicolon, double, my double value equals 5, semicolon. Before we continue, let's quick talk about 2 other numeric literal suffixes. Earlier, we learnt that the letter L is used in a whole number literal if the value is greater than the int's max value or smaller than the int's min value to specify a long value. The suffix is optional otherwise, but you might want to use it to self-document code. Important, the double data type is Java's default type for real numbers. For example, any number with a decimal is a double. So 10.5 is a double by default in Java. The double data type can be specified as a numeric literal with a suffix of either lowercase d or uppercase d, but because doubles are the default in Java, the suffix is optional to use. The float data type can be specified as a numeric literal with a suffix of lowercase f or uppercase f. This suffix is required if you are assigning a real number to a variable that was declared with a float type. Much in the same way Java has chosen to use an int as its default data type for a whole number, Java uses a double for its default type for a real number. It is important to note that Java did not choose the smaller and less precise float data type. This is because using a more precise data type generally outweighs the benefits of using less memory. Unless you're absolutely certain you don't need that additional precision in your results, it's best to stick to using a double rather than a float. So getting back to our code, notice that we haven't put anything on the end there of any of the number 5s. What I mean is we haven't included a suffix in the numeric literal that we assign to any of these variables. We just used a simple literal 5. You may remember we used a nil suffix when we wanted to specify a long literal. But you can see we did not put an f, d, or any suffix there, and that's been accepted and executed fine. What this means is we can assign an integer literal to both a float and a double variable. You can put an f or d there to confirm the data type. It's good practice to do that in general if you're typing in literal numbers to make it abundantly clear what you intend them to be. So let's do that now, first for the float variable we previously declared. My float value equals 5f semicolon. And then for the double, my double value equals 5d semicolon. So you might have noticed that we got the same output whether we use the suffixes or not when we assign a whole number literal to these variables. That works fine for a whole number, but you'll find that if we add a decimal 0.25 to make it 5.25, a decimal number. Now, if we remove that f there, we will actually get an error. Let's try to declare a new float with a value of 5.25. Float, my other float value equals 5.25 semicolon. And now we get an error. The reason we get this error is, as previously pointed out, the double is the default floating point number in Java. So here, we've got a similar problem to what we saw with other data types in previous videos. On line 2 of the output, you can see that Java doesn't like trying to put a double into a float variable type. In this case, the literal value that we've typed in, 5.25, is being interpreted as a double. Alright, so next, a quick challenge for you. Thinking back to our discussion on casting, how do you think you'd do the same for the float to remove this error? So have a think about that. Pause the video and try it out and see if you can get it to work to remove the error. When you're ready, come back and resume the video and we'll go through the solution. So pause the video now. Okay, so welcome back. Did you get that working? If you remember, the format of the cast is the name of the data type you want to convert to, a float in this case, inside the left and right parentheses. Float, my other float value equals opening parentheses, float, closing parentheses, 5.25 semicolon. I usually add a space there between the cast and the value just to make it clear. So what's happened here is the error has disappeared. That's because we're telling Java, yes, this is a literal double that's been typed here, but we want you to treat it as a float, and for that reason, the error then disappeared. It's generally not recommended to do that though, for a couple reasons. Firstly, as I'll talk about in the next video, floats aren't usually recommended to be used much these days. Double is the preferred floating point data type to use. But secondly, it's a lot clearer, I think you'd agree, to just add the letter F right at the end that tells you, okay, that's a float. Float, my other float value equals 5.25f semicolon. And that's generally the format that most programmers will use. They would use an F suffix to indicate the type rather than explicitly cast it, which is just a little bit more code to look at. Not everyone realizes that Java's default data type for a decimal literal is a double, which is larger and more precise than a float. Java likes to put a similar line of code in its code segments on exam questions to what we saw earlier, omitting that F suffix. Without your compiler or IDE, this statement can look fairly innocuous. The number 5.25 is a double, so assigning it to a float will raise an error. This is a gift question to an exam taker if you can easily spot this compiler error. Just remember, in Java, a decimal number literal is a double. A float is less precise than a double, so you cannot just assign a less precise value to a more precise variable type without using a suffix or explicit cast. Alright, so let's finish this video here. Next, we'll start exploring more about these floating point types, and we'll start doing some division to see what happens and what those numbers will look like. So I'll see you in the next video.